1 second. Castling consists of moving the king 2 squares forwards a rook on the player's first rank, then moving the rook to the same square over which the king crossed. Castling may only be done if the king has never moved, the rook involved has never moved, the square between the king and the rook involved are unoccupied, the king is not in check, and the king does not cross over or end on a square in which it would be in check. Castling is one of the rules of chess and is technically a king move. Ooh, okay. As I see then maybe. Yes, makes sense. Makes sense. Refers to a maneuver in which a king which has lost the right to castle achieves a castle position in several normal moves instead of one special move. So let me see. Okay, so I guess actually the way to do this move would be to make it possible for the king, as it says, is technically a king move. The notion for castling is both the descriptive and the algebraic system is 0-0 with king side rook and 0-0-0 with the queen side rook. Castling on the king side is sometimes called castling short, and castling on the queen side is called castling long. The difference based on whether the rook moves a short distance 2 squares or a long distance 3 squares. Castling was added to European chess in blah blah blah, doesn't matter so much. Castling is permissible, provided, is that it? Permissible. I need to look this up. Permissible. Castling is permissible provided all of the following conditions hold. The king and the chosen rook are on the player's first rank. Neither the king nor the chosen rook has previously moved. There are no pieces between the king and the chosen rook. The king is not currently in check. The king does not pass through a square that is attacked by an enemy piece. Through a square. Interesting. One may not castle out of, through, or into check. It is a common misconception that the requirements for castling are even more stringent than the above. To clarify, the chosen rook may be under attack. The rook may move through an attack square provided the king does not. The only such square is the one adjacent to the rook. When castling queenside, the king may have been in check earlier in the game provided the king did not move when resolving the check. Okay, so I guess we try to implement it. What keybind is this? Alt-Shift-C. Okay, so maybe I should map it out, I'm not sure. I could also change the pieces on the board. I might actually do that. Let's move some stuff around here. Let's see, this one goes here. Queen we just send up here. Okay, so we have this right. Interesting. Okay. Okay, so I guess I need some state here on the board piece setting. So let me check this set board piece out. Come on, jump. Set board piece. So if I need like a first move here, so I guess I could put has moved. Okay, so I guess we make a function, so static do Casteling. Okay, so Casteling move. Do Casteling, and how? So I guess what I can do is let's do this, and we do so what we want is okay, so 2 squares, right? It was 2 squares, I think. It's a king move, and it is Yes, so 2 squares from the king, and it's a king move, meaning I can display it in this way if somebody picks up the king, and then the king would have to go where? Because let me read this again. A castling move is castling consists of moving the king 2 squares forwards a rook on the player's first rank, then moving the rook to the square over which the king crossed. So moving the rook to over I'm a bit confused right now. I need some more examples. Maybe here. Okay, so the king. Okay, so the rook goes to the other side, meaning that this one would go here, and this one would go here, right? Or what? Yes. Okay. And the king would go here. Whatever. I think that's fine as then. So we display it if the rules are correct. Then we make this move possible. So right now what we have, so let me move one of these. So we have this, and in this case we need to display a green here, or we basically need to make the rule for it, right? So how would I do that is the question. We have a function called doCasteling, and this happens when certain conditions are met, and one of the conditions that have to be met is the has moved. So we need to check. Oh, this is where it might become difficult. Actually, will probably be very difficult, because in this current case I would have to, what would I have to check for? I would have to check if this one, so let's see if I can write something here. Check if the rook has not moved. So a player picks up the king, and there's a check. Check if the rook has moved. Check if the king has moved. Or I guess I can just say has, or maybe it's have actually. Have moved, right? Check if the king have moved, and check if any pieces is between the king and the rook. And what more do we need? We need to check if the king moves over an attacked or a field under attack, right? I think that's it. So let's see again, I guess. So the king and the chosen rook are on the player's first rank. Neither the king nor the chosen rook has previously moved. Okay. There are no pieces between the king and the chosen rook. Yes, the king is not currently in check. Okay, so I guess I need also to check that. The king does not pass through a square that is under attack by an enemy piece, and the king does not end up in check. This one is where this is where I'm like, this is kind of stupid, almost. Because if you move in check, right, you lose the game. True of any legal move. Okay, so I suppose this is actually a rule I have to implement as well. I don't agree with implementing this though, because I think people should be able to know the rules and then just not move into a losing position, because that's kind of the game, right? Anyways, so do castling. So first, what we will do is that I pick up the king. So let's say we pick up the king, and that's the current piece. The current piece is a king and has not moved. Is it has or have? I'm not sure. Okay, so it have not moved, and so if this is true, the king have not moved, then I guess we go on to check if the rook has moved. So I guess this is where I need to check where I call these rules. So I call the rules down here. And this is fine because this, I guess this will go to the coloring. And that's the first case we need to fulfill, is to make the move seem possible for the player. And so furthermore, what we need to do here is we have a current piece. Start move state. I could also remake this actually. Or no, never mind, I cannot. Do castling. So chess, if chess dot current piece rule name equals king, and chess current piece dot has moved is false. I guess this is where I should say has not moved actually. I think I'll change it to that. I'm not sure if it's has not moved or has not moved or have not moved. Does it have not moved? Oh, had is also a thing. have not moved. Chess current piece rule name king, and chess current piece have not moved, so these are true. And after this we have to check. So this is where it becomes difficult, because the current way this works is that the king moving to this square, like it would be way easier here if this move were displayed over here, but I think the way that they want to display it is like this. Maybe it would be way easier to implement if I did it over here though. So okay, so I guess we check this first condition, and then, well, so this is just a lot of conditions that have to be true, but the difficult part here, I guess, I guess it's not that difficult. I guess I just check if it's a king. If it's a king, so do Casteling, we call somewhere down here, right? So if rules.doCasteling return something, then we return something. Maybe true here. And what then would have to be done? So we check the current piece, it's a king, or no, we don't actually have to do that because it is a king. We know that, so I guess we check if the current piece has moved, and then the other condition we would have to check is that we would have to check if it's this square, we would have to check the condition of this one, and if it's this square, we have to check the condition of this piece. This is where it becomes tricky, because this move have to work in every case, but I guess they always have a position, right? They have a position on the board, meaning we can probably use the position on the board, meaning we can maybe check chess.board for certain fields. So this one is currently 0, y equals 0, maybe I'll write that, equals 7, just to make it something, and up here we have x equals 7 as well. Okay, so in either cases, so here it is, yeah, maybe I should not have written it like that, but let me actually I guess it's easier for me if I do this. So 0, 0. I'll delete these then. And this one is 0, 7. Zero. Oh, I did move that, or what? Why did it go here? 7. Here we have 7, 7. So, I guess the question is now, how do I make a check that can check any of these pieces based on a certain movement? So in this case, maybe I should actually let me do something here. I'll move these pieces. Okay. Okay, so it's fine. It crashes because of the new movement I'm about to implement. So let's see. So the king has not moved. And it would have to work for each of these, right? And if this is the way I want it to be, if this is the way I want the move to happen, then I guess I would need some rule here. And what rule would that be? That's the good question. So let's see, the field I move to, let me see if I can think something up here. So in this case, it would move, I'm just gonna write M or something. So, and M is for a move to 0, 6, right? And here it would move to 2 or 0, 2. Because, you know, I don't want it to, like, it's easy to implement if you just do a lot of if statements, right? If I made a check for each, is the place I want to move to this spot, or is it this spot? Then check for this, then check for this. But I think there is maybe a more optimal way of checking each of these pieces. But the question is just how. The question is just how. I guess maybe I could do something like, no. So here it's 2. 1, 2, 1, 2, 6, 1. Interesting. So 1, 2. There's 2 fields here and there's 1 field here. King has moved, and also the big problem here is that if I want the move to be fulfilled in this way, right, I guess maybe I should just say fuck it and then make the move happen, because if I make the move happen in this way, right, over here instead of on this square, it's way easier to do, to be honest, because then I can get the mouse position of the field. It's just that if the common convention of doing a castle move in usual chess engines is this one, then maybe it's confusing if I choose to make it over here in mine, but it's just way easier programming wise to make the move happen if you hover over the rook, because then I can just get the state of the rook, right, and then the movement would be pretty simple, I suppose, because if I move the king here, where does the king have to go? The king have to go. If I move the king here, okay, so the king have to go to this field, and the rook have to go to the field on the other side of the king. So, I mean, the king is easy to move here, right? Now maybe I should have it like this. And then how would I do? The problem now is figuring out a way that is that would work for each of these values, or check for each these values, right? Based on where I want to move the queen or the king. So if I move the king here, I would have to get 7-7, right? And this one is 6-6, right? So I'd have to get the array fields of 7-7 without a statement, without doing an if statement for it. I don't want an if statement for each of these, but I want like a mathematical formula almost that knows if I makes this move, it's automatically gonna get this, and if I make this move, it's automatically gonna get this. So, but I'm not sure if there is any like a general formula for it. But I'll see if I can think. Yeah, this is definitely probably the hardest move to implement, I think. Because there's so many conditions that have to be fulfilled. There's so many checks, and then the board is not it's not, what would you say, like the king is closer to this one than to this one, so there's already like a non-similarity between these two pieces. So in each case, the rook would always go next to the king, or where the king was before it moved. So that should be fairly easy, I guess, to do. The thing is, these checks of the rook's condition is the hardest ones. So 7 0 0 0 0. We move to 0 2. And here we move to 0 6. Here we move to 6 6, and here we move to oh no, it's not 7 or 6 6. My bad. It is M is 7 7 6. And here it is 7 2. Okay, so I guess we see some kind of pattern here, right? These, they are always the same, and these are always the opposites. So maybe, what could I do here? This is where I guess you just do some checking or testing of this. So 6 6 and 7. So this is always the opposite, right? It's always the opposite, meaning that maybe I can do something here. And I might be able to use this number 2. I'm not sure. So let's say I move here. I want to do this, the 7-2 move. What would then happen? So I would move the mouse. So the mouse would get these values. And when that happens, I would have to get this piece. So 7 would not be touched. Okay, so the y-axis would never be touched. That's good to know. Meaning that I only have to work with the x-axis, right? Yes. So I don't have to care about the y, but the x. So if x is 2, x equals 2, x equals 6. So let's say x equals 2, meaning we would have to get the position of 0. So how would that happen? What happens if I do 7 minus 2 gives 5, 2 minus 7 minus 5. And maybe I should do this in here actually. So let me get some values, then it's maybe easier. So the current piece we don't have to worry so much about, but the chess.mouse.a. So let's do y equals this and x equals this. And let's just do it up here. So we have these values, and what can we then do? So the current piece has a value, and what value does this king have? The king have the value of 1, 2, 3, 0, 1, 2, 3, 4. So the king have the value, so let me see, king, let kx equals 4. So what about 4 minus 2, that's 2. 4 minus 6, that's minus 2. Seven minus 6, that's 1. 7 minus 2, that's 5. 1, 2, 3, 4. Hmm. 5. Okay, so this is 1. What happens if I do minus 4? Minus 3. That's no good. Seven, 2. I guess this king position does not matter, and the y only matters in which way, I guess I can ask. The y does not matter. Okay, so the y just have to be stationary, right? The y have to be stationary, which it is, and that's okay. But we have to do some calculation on the x, which gives us the field we want, because we would have to ask for. So these are the values we would have to ask for, I suppose. And y would always be y, but x would have to be some kind of mathematic formula. And how I get the right one, I'm not sure. So, because in this case, it's one more, right? But I guess we can probably use this for something. We should be able to use this for something without doing an if statement, right? Because the if statement is not as cool as having it just working without if statements. So we have the position 0, 2, and we have the position 0, 6. And we have the king equals 4. Or the position 4, right, on the x-axis. So the question is, 2 minus 4, that gives 2. And 4 minus 6, that gives 2 as well. And we can use that for nothing. But, okay, so 7. Okay, so maybe. Okay, so the mouse moves to. Let me see here actually. The mouse moves to either 0, 2 or 0, 6. 0, 2 or 0, 6. So if it moves to 0, 2, what can we then do? So minusing the x here would give us 2, and it would give us 2, and we can use that for nothing. but maybe we can use this for something. So 2 and 6. So what happens if we say 7? 7 minus 6, that's 1. 7 minus 2. Yeah, let's give us 5, which is almost good. So 2 minus 7, that's minus 5. It's also not good. So 5. How do I use this 5? There must be a way I can use this 5 for something. So in this case, I have to move 2 fields on the x-axis, and the value is 2. But here, I would not have to move 2. Here, I would have to move 1 on the x-axis. And how I do it, I'm not sure if it's even possible without an if statement. Maybe it is. Because in this case, when x is 2, I could just say, you know, so m1 1 minus x, or x minus m1, right? I think, meaning that we would have 2 and we want minus 2, which would give us 0. Okay, so that would give us 0. And here, if we would apply this down here, we would get, so 6. I don't know what I'm doing. This makes no sense. Of course this would give 0 if this is the case. Stupid. And it would also give 0 here, of course. I mean, I guess I could drag the king here to the field and then check the next field, but then I would have to check the field after that as well, which is not something I would like to do. But then again, oh, maybe we can use this. So 4 minus 7 gives 3. 7 minus 4. 7 minus, or 0 minus 4 gives 4. Interesting. Interesting. So maybe I can use this for something, because 7 minus 4 gives 3. So 7 minus 4 gives 3. 3. 3 is the number of fields, right? 1, 2, 3. If we plus on the x-axis, or is that wrong? 4 plus 3, 3, that gives 7. Yes, it gives 7. And in this case, what is it? So 4 minus 0 gives 4, yes? Or, but how do I get this value? That's the question now. How do I get 4 or 7? So we move here, we get 6. We get 6. And we have 4. Four minus 7, that's 3. 4 minus, it's 4, of course. But we don't have this value of 0. Or do we? Do we? So 6 minus 2, we have a value of 2, and we have a value of 6. So we have a value of 2, and we have a value of 6, and we have a value of 7 maybe. So 7 and 0. And 0, and we have 4 as well. So 4 minus, or 7 minus 4, it's 3, right? And 0 minus 4, let me see, 0 minus 4, minus 4. So here is 3. Fine. But then again, where do we get these values from? I cannot get these values. But what I can get, because I think I'll just have to write a lot of stuff here. So 2 minus 4 equals minus 2, and 6 minus 4 equals equals 2. So this is the places the king will move. It would, this is one of the cases where it would be the easy way would be just to make if statements, right? And if I had made if statements, it would be done by now almost. So let's see, can I do something with these? Okay, so 2, 4 plus 2, that gives 6. 3 plus 2 and 6. Move to field from Okay, so the castle move here, and we have the value of 0, 6. And the 0, because of it being y, does not matter. Y does not matter. Or it does matter, but there has to be 0 calculations on y. So 6. I need a way for this to return 1. Let me see. What is 2 minus 7 and 6 minus 7? Or the other way around. 2 minus 7 is 5. Just do this. Equals 1, right? So this would give 7. 2. 2. So in this case I could plus this, right? I move to this field and that would give 7. So this would give 7, right? And here we have 1. But wait a minute, this does not have to give 7. This have to give 0. This have to give 0. So 5. And if I minus with 4, you know, it gives 1, right? But that's not good. It's not good. And here, if I minus with 4, I get like 3 or something. Minus 3, right? So I can use these for nothing, to be honest. I'm not sure if I can even do this without an if statement. You know, I could always just say if this is this, then that, you know, 1 is this chess, is this for a chess AI? No, the current thing I'm doing is just the Casteling move is like a special move where the king have to, maybe you know, but I would like to maybe do an AI after, when I have the game sorted out, right? But right now I need to, like, this is the last move I need to implement, then I have all the moves in the game, and then maybe I can do something else after. But this is just this simple move, and I'm trying to do it without an if statement. So I'm trying to do it or see if I can do it. Maybe I should just look it up, right? But I'm trying to see if I could do it by multiplying or minusing the values of the fields, because right now the way that the castle move is going to work in my game is that you pick up the king and then you move it to this square, and then by doing this it have to check these conditions down here. So it has to check the rook next to it, and both of these, they may not have moved before in the game, but that's not the difficult part. The problem I'm struggling with here is that there is a field more on this side compared to this side, so it's not similar in width here, or whatever you want to say, and I'm trying to do it in a way where I don't use an if statement. Like, it would be very simple to solve this if I just said, oh, if it's so, you know, do this, else do that. And it will probably just be one if statement. But I would find it more fun if you could do it by subtracting some of the numbers from the squares you get. So if I want to move to 0, 6, because my chess is based on an array, so I don't write the other numbers. Or if I move to 0, 2, which is this field, then I would have to check this piece. And if I move here, I would have to check this piece. So I'm trying to figure out a way where I can do some mathematics on this field and this field. Like a formula that works for both this field and this field. I don't know if you can do that, but that's what I'm trying to think up, and I don't really have any luck in it. And you probably would say that I'm reinventing the wheel or something, because maybe even, you know, if this is possible, I could probably just look it up, but that's not really what I'm doing. Anyways, I might just do the if statement, because this is taking, I've been thinking about this quite some time now, and it doesn't seem to get me any closer. I don't get any numbers that seem to be workable. So, you know, an easy way would be if x is equal 6, then we do this, you know, else we do the other, and it would be this if statement or something similar to this if statement, which is not very much anyways, but I would it would just be cool if it were another way, I think. But anyways, that's how it is, I suppose. Because this would always also work, right? And it would just be that the difference would be, instead of having a formula that somehow could solve both cases, we now need to have an if statement that checks if this is 6, then we have to do this, and if the other one, then we have to do that. So in this case, maybe I should just do this, and then maybe I get another idea or something. So in this case, we would have to check y, and we would have to check, so x plus 1 essentially, and here it would be something like x minus what, minus 2. It's just that it's not that like the thing I'm doing doesn't have anything, or the problem I'm trying to solve for myself right now doesn't have anything to do with doing loops. It doesn't have anything to do with not the problem I'm trying to solve, right? It's not about checking fields, because, you know, that would be a simple part. It's more so getting the value of this piece. That's the only thing I'm trying to solve right now, based on the movement. So if I move to 0, 2, I get this square, and if I move to 0, 6, I get this square, and it would work similar down here, because it would only be the x-axis, right? You know, the horizontal axis I would check on. But what I was trying to do was get around doing an if statement for it, and not getting around doing a loop or something. Maybe a loop could work, maybe I just don't see, maybe I'm missing something. Yeah, maybe a loop could actually work too. So why doesn't this work? -2, this gives 5. Why does this give 5? Because in this case I would have to minus, so 6 minus, or 7 minus 6 would give me the number. Wait a minute. There is no real benefit of avoiding an if. It's just or I guess you could say the benefit would be instead of doing a check, you do a mathematical computation. And I don't know, you know, the if statement might be faster, but the other would be less code, because of I would be able to remove here. I have to do a check yx, right, some function, and I would have to do the same function here. But if I could do it without the if statement, I could just have the check out here, and I would be able to remove this code. So I would save quite some lines for it. And it was basically it, because then instead I could write something like x minus 7 divided by 2 or something, whatever the formula is, right? And maybe it's because I don't think about division or something. What is 7 divided by 6? Three. So that I guess you can say that in an industry environment, you would not look for this, right? But it's more because it's a hobby, like a hobby project, you know. So for me, it's kind of like thinking of if I can do it this way, and it might be possible. Maybe I can just not see it, right? So it's kind of the case where I just try things, right, and see if it can work. Less code is the only benefit that you can gain from it. Nothing else really. Because here in this function, or in these checks, I would have to call, let me see if I can find my get piece or something, if I even have one. So find piece on array position. So I would have to call this function in here with the y and some x value, and the same down here. So you can see that it's almost the same, right? The only thing is just that here, or maybe, you know, I would probably do this, right, and then remove it from here. So this might only be the mathematics that is happening here. Could be let's see if this is even right. So this is on position 2, and we -2 because we want to go to 0, and here we want to go to 6, right? So this could be done, and then we ask for like this. We ask for this piece, and then we have to check on this piece if it have not moved, and if this is true, then we do something. I am new to programming and wondering if I should use Linux or Windows. I don't think anybody should be able to answer that question for you. I'm sorry, but whatever works for you, right? If you like Windows, you use Windows. If you like Linux, you use Linux. Or maybe the best way to answer it could be that dependent on what kind of programming you have to do, you choose your operating system. So maybe if you want to do something very like something with machine learning or something, right? Maybe Linux would be better because they, in some cases, have, or I don't know too much about this, but I know that Linux have better GPU support. If you want to do something like a TensorFlow, it's probably best to do Linux. And maybe if you want to do Microsoft programming, there is no way to go with, or if you want to do Microsoft programming, I don't think there's a way to, or a reason to go with Linux instead of Microsoft, because most of Microsoft products works best on Windows. That's usually the case. So maybe that's the best answer I can give. I don't think there is a, this is better than that. It all depends on what you have to do, I think. Maybe you should, or maybe we, in general, we should see it more as okay, makes sense. What if I'm into backend programming? Well, it depends on what kind of backend programming you do, I would say. The case, if you, maybe if you write like C#, right? I know C# have it has or have some kind of Linux support, right? With, if you use, I don't know if it's like C# mono or something. I don't know what you call these things, but there are certain things, because maybe it's made by Microsoft, then it's more difficult to make it run on Linux. So you need other things to make it work. And yes, like OS doesn't make so much of a difference. It's mostly what you write, and then based on what language you need. It doesn't matter. It doesn't matter at all, I would say, almost. Only if you need a certain yeah, if you need like GPU, then maybe you GPU for machine learning with TensorFlow or something. You have to do that, or certain things they just don't run on certain operating systems without you doing something special to get around it. So I think that's what you need to know, or take into consideration when picking your operating system. Maybe I'm not a fan of Windows, but I use it anyways, right? Okay, so let's see if I can make this rule. So we check if this has moved, we get the piece, which is this piece, the rook piece. Maybe I should call it that actually. No problem. I use C on Windows with GCC. I'm sure dealing with the OS is different on Linux, but that not much. I use a copy paste that creates the window. Okay. Yeah, there's certain things like as he said, Genos, I guess. Certain compilers, they might be Windows compilers, or they might be Linux compilers. Again, it depends on the language you use as well, as far as I know. Okay, so we check if this have moved, and we check if this has moved. Do you have any tips on learning to program? Where should I start? Any do's and don't? Find a project and get coding. That's the best way, I think. Just start doing it. Find something that's fun for you. Don't care about so much what others do. That's the best, or that's my take on it at least. Do something that's fun for you and learn by that. Yeah, you could start with hello world. That's very simple. Okay, so now I would need to check the pieces between here. So the question is, can I use my current collision detection for this? My collision detection might actually cause problems. Yeah, do something you want to do. Okay, so my collision might mess with this because, or no, there's no collision actually, so it might be able to get around it. So I would have to make like a specific collision for this, meaning, so let's see, we get the start y equal chess dot current piece dot array position. So I need some function here that runs from. So we don't care about the start, but we care about the x, and we care about okay, so start, I guess the start x, let me see, start y is the current piece, and where we have to move to is x. So start, yes, start x, but it's always gonna be the same, so I might not even want to get it from this one. I guess I could do it like this. Because it cannot be other than this, so I don't actually need this. Do you already have a function to check if the king end up in check? No, I don't. That's actually one of the things that's like the last one. After this, that's gonna be the last one. But I need it in this one as well, so they're probably gonna be finished in like same time. So we have the start x, which is 4, and here we have 7 and we have 0. So let's see, start x, we minus start x. So how, I need some loop here, like that's for sure, like 100%. I'm just not sure how this loop will work. But let's say we so x start is 4. 4 minus 7 gives 3. 1, 2, 3. Oh, maybe this is where I do something. So 4 minus 7 gives minus 3, and 0 minus 7 doesn't make sense. So 0 minus 0, 7 minus 0 gives 7. Minus 4 gives 3. 4 minus 7 gives 3. What did I do up here? I think I pushed something into an array for the collision detection. Yes, I pushed this. Maybe that's what I need to do, or I can do. So here I could have an array at a, I'll just check this out. Or actually it's just gonna be a value. In this case it's gonna be equal 1. In this case it's gonna be equal minus 1. It's probably a better way, but so we have start, which is 4 because that's the starting position, and we want to check forwards. Yes, maybe this is where I make like an array or something. Actually, let me actually try that. So this one is going to be 7, and this one is going to be this. And we have to go from 4 to the last position in this array. I like Visual Studio Code, if you ask me. So this might actually work, and then what we would have to do is that we find a piece here. We find a board piece and what do we do with it then? So y, and then we take I, I like Visual Studio Code more than all those examples, if you ask me. I used to use Atom, but I think certain things they are better in Visual Studio Code, and it's also free. So the question is what I do with this found piece. Or this is going to be the square, right? And the square is containing a piece. So. And the king. And the king must not pass over a field which is under attack. Oh, this is so difficult. God damn it. This move is very difficult. Yeah, programming the religion of the future. Okay, so we get the mouse piece here, X, but we changed this, meaning that in these cases I would have to check. So if it's in the range, if I is in the range, does that make sense? If I is in Okay, so the king moves. Are you gonna make your own neural network? I hope one day. We gotta get these rules in check first. But I would really like to try it out, to make one so I get the understanding, not just of the framework. Oops. Okay, so mouse position is where we move to. Where we move to. Is where we move to. It's gonna be 2 and 6. 2 and 6. Let me see. Okay, so I plus equal here. I'm getting myself into some troubles right here, that's for sure. Wait a minute, I don't even use X. I use X to find this piece. Use X to find this piece. I might not want to do it this way, because I'm changing the value of this. But then again, I can just use this, so I guess it's fine. A is the current, so this, in this case it's gonna be 2 or 6. It's gonna be 2 or 6, and I need a way to check if so in this case I will either go up, I will either go to I will go to 0 or 7. And we have to wait. This is where I might just add an extra here, because doing this would probably solve it, but then again, I'm not sure if I want to do this. So meaning I could do incrementer and get the value here maybe, and then so when I is the problem here is that I cannot do I'm not sure about this check, because this is the king, right? This is if the king moves into check, I guess sorry Draxler, I'm seeing this first time. Oh no, you don't, it's not that you need to help. It's just that I'm trying to think out loud. To you know, it's also the fun part is doing this myself, right? Anyways, sometimes help is nice, but I also want to do something myself, right? So the thing I have to check for here is that I have to get each square. I guess I can make a comment. I have to get each square the king passes and check if it's a check condition. I could probably simplify it, but you show me, I guess. Oh yeah. Suggestions and help is always just check for king is under, check for a. Yeah, but it's not the check for the king that I'm trying to do now. That's not the piece of code I try to write. I'm trying to get this if statement correct, and that gives me the squares the king passes. So we have the king, right? We have the king here. I guess I can maybe simplify it like this, or show what I mean. So the king has to move over here, right? The king moves this way or this way, and it's gonna end up in this position. And by doing this, I have to check this square and this square and this square. I guess it's more simple than I do it maybe. I guess I can just say if I minus this is less than 2 or something. Let me check this out. So 4 minus 0. So this will be the first field, 3. So this is less than 2. Or I guess I can do or. Maybe that was what I did not get. Or if I minus 7. So what is 4 minus 7? That's 3. 4 minus 4. Minus 6. So it ends up on 6, which gives 1. Yeah, this doesn't work out. I guess I can do if I is less than, yes, I think this might work. If I is less than, so I don't minus. If I is less than, I think that's a problem. If I is less than equal to this, or if I is greater than equal to this. Right, so if I which is 4, is greater than equal to 6 is 2, and it goes to 5, and it goes to 6. So that would work. And then the other case would look like if I4 goes to, so it's greater than equal to 3, 2, 1, or no. So if 3 okay, so this is where I need to add and I need to add an and. I need to add and, so if 3 is greater than and, so this case is the down, going down, meaning you could have a pre-calculated array with 3 unoccupied positions. I have an array with, but not with, I have an array with positions, and that's what I'm trying to look up the array with positions, right? But I'm just trying to do the Boolean logic because it only have to check these two fields when I move the king, right? So I'm just trying to do the logic for it. Nothing else actually. And I know how to make this work, this thing. It's just that so if I is greater than, or if I is less than this, which is 6, we go on, or if I is less than or greater than 2, and I might need an AND case here, and I don't know what you're talking about. With an array you could look up if the position is 0, 3 or not. And that's what I'm like, it's not difficult for me to look it up. That's not what I'm doing. Because this one would go here, right? This one would go here, and then this P is holds the value of the field or slash square. Oh, okay. It's just that I cannot get this logic right in my head. I just need to think a bit more. So if I is less than the increment, which in this case x 8x global array, he means, I don't know. I have an 8 times 8 global array. I don't know if that's what you're saying, but like this function here checks in this board, checks on the x and y in the global array and returns the piece of the position. But the thing I'm doing right now is writing the logic for the king check, right? And then furthermore, I would have to implement this function if the king is in check. And then when that's, yeah, whatever. It's just this logic. I cannot exactly wrap my head around it, also because I keep swapping back and forth. So the increment in this case, right, is 6. It's 6 or 2. 6 or 2, and I is from 4 to 0, or from 4, let me see, I goes, yes, so this one is if I is less than greater than 2, which means that I is greater than 2 in this case, or I is less than, so in this case I guess we say greater, and if I is greater than 2, and if I is less than equal 6, let me debug this actually. Alright man, have fun. I'll check this out. Oh. It's also because there's so many checks here that has to go on. So where did it fail on? It failed on mouse. The mouse is undefined. Because of what? Because the chess is undefined. Because I don't pass the board. So we get the mouse, X and Y, that's good. It's good. X is equal 4. Yeah, this is not very good because it's gonna jump down here then, and now X is 4, which means it's not really doing the check. So I guess I might need some. I might need to encapsulate this into something. So if so it breaks when it gets out here because it returns false. Find board piece is not defined, of course. Makes sense. So let's see. We go here, we can go here, and then we get out here, and it doesn't break. So this is good. At least then we can debug. So let's try to debug this and see what it says. And we have to jump over these cases. Okay, so we are in the right field now. And we see. So current piece have not moved, that's true, or that's false. You see, did I not have not moved? Oh, I guess I need to set this to true, right? Yes, okay. Let's try again. Go here. Get in here. This function works. Let's see. We get the rook based on 7 and 0, which is this one. That's good. We get into the function that have to check for collisions between the king and the rook. and something happened. So we wanted to go to 0, and here, yeah, here is a problem. Here's a big problem. It's a big problem. If I want to have it all in one for loop, I'm not sure if, can you do like double here? Can you do like if this or this? I never really do anything like this. So if I is greater than, let's try. Okay. So what happened? It broke. Why did it break? So okay, we can jump in here. So in this case it is 2. If I is greater than equals 2, then we run, so we get the piece, and this is failing, so that's fine. So I guess now I can actually, I don't need to debug. Okay. Move these. How many does it print? It goes 1 too far because of this, I think. Still goes to 1. We should not see 1 here. So I is 4. We decrement by 1. So I is 3. And we actually have to ignore, I think we have to ignore, I guess we have to ignore the first, so I might have to remake that. It goes to 3, that's fine. So what happens here? I is 1. Yeah, the king moves. No, the king moves, and I think it's based on the king. It's a king move. I'm pretty sure it says on Wikipedia. Casteling is considered a king move. That was the reason why I chose to do it this way. Anyways, so if I is less than, so okay, which case is true here? So 2 if I is less than and, so this is where I need an and, so this condition will be fulfilled. I think I do need equals, so this is where I would need some kind of and condition over here. But what do I need and with? And I okay, but the rook needs to go near the king, and the king always moves 2 spaces. Yes, you move the king forwards the rook, and the rook jumps on the other side of the king. So when I move, if I move the king here, this one would jump here, and the king would jump here. I have these very bad lines, but the king goes here, and then the castle goes on the other side of the king. And the same here, the king goes here, and the castle or the rook goes on the other side of the king. But I don't think that would be very difficult to do when I have the logic here in place. So increment I is less than 2. I guess I could do, and this is where I could do something very simple, I suppose, and or something not very smart, but it will work in any cases. So and this is equal or equal I first learned about it now by doing this. Actually, I'm not a big chess player, so I learned about it by doing this. So if I is greater than equals 2 and I is less than this, and I mean, 6, could do this right, and then encapsulate it one more time. So let's see if this works. I'm not sure. So we have this. We print 4, 2, yes, that's good. And one of the things I could do to fix this I would be to say plus increment to 0, right? So 4 plus -1. I'm not sure if you need a parentheses here, but so 3 and 2, that's the right numbers. And if we go to the other side, we get 5 and 6. And what about up here? Okay, so we cannot move that. So let's do this. Interesting. We get 5 and 6. That's very good. Look, it's working. That's good. Very good. So this gives us the pieces of the squares between the king. And then the question would be, so I probably need some if here, right? So p dot, and this is where I need to do something that's not very good because of the current structure, but let me just get it working. And I would have to check on this rule name actually, or a piece name. I guess I just say icon equals this. So if this is not equal this, then we do something else, maybe we return false or something. And here, what would we have to do? So this is just checking the pieces. But then again, I might not need to do this because I already think I have collision. Right? I already have collision detection. So this might be totally wrong, I'm doing this. But I would need this value anyways. Meaning that this value would have to go to... So in here is... in this if, the fields the king passes, so check for is in check or something. So I would have to call this function, so rules dot this, and we have to pass these values, I suppose. This is where so how would I check if the king is in check? I guess I run through all the pieces, right, and would have to check if any of the rules are fulfilled. So I guess I have to do something. I pass chess here, so chess.board board, and we would have to loop over this, I'm pretty sure. So or maybe I should not do this here. I might want to do it on the chess. I think I'll actually do that. So we do is in check, and this have to return this dot board. So let me see, chess dot this passes the y and the x, right? Y and x, yes. The y and x is the king position. So I guess I would need, no matter what, to do this. I've done sometimes before, so let me get this function. Is this the only way I do it? Yes, the conditions are like that. That's why it's a bit difficult, because it's quite some things that have to go on. But this should, I think I know how to do it. It's not that difficult. So here is where I get all of the pieces. I would have to run through all of the pieces on the board, and then I would have to check check on something. So if some case is true, then we return true, else we return false down here. So this gives us the piece. This is the king piece. So this piece should be able to call some, we have rule on this. So let me see what I actually do down here. Attack is ally, so I might be able to just say this rule and then pass this to it. So rule, and we pass this. So what happens here if we do this? Because how would I know which piece is on the board or which? You could probably optimize it, but I think I have to run through the entire board to know if, you know, if a queen stands here, or, you know, maybe I can do, maybe I would only have, but I'll just do everyone. That's easier, because let's say you have a knight. Let's say I have a knight somewhere. I cannot even move this. But let's say I have a knight here. Then I would have to check, you know, I would have to check this directions, and I would have to check for knights. And I already have the rules in place. So the easiest implementation of it is probably just to run through the entire board and check every piece instead of optimizing. I could optimize it so it would only check for the diagonal fields, but then I would have to rewrite certain things, and I could not just do this dot rule if this is true. Let's see, rule. Because I think this. Yeah, I'm gonna check if the king is in check. And the easiest way, you know, you can optimize it. I know, but the easiest way would be to just run through the entire board, right, and then check every piece and the rule based on that piece. Like you could optimize the algorithm, right? But I don't think I'll do that. So the problem here with what I do is that the current piece in these functions, which are the rules if the condition or if the move can be made, the problem with this is that the current piece like my current structure does not work, so I need to do something with this to make it work. But what I can do, I'm not quite sure of. So I get the mouse position here. So the mouse position, and in this case the mouse position will be the king position. So maybe I can do like a trick where we bind this mouse position and then maybe optimize it later or something. But let's see. So we can say this dot mouse A equal Y and this dot mouse X equal or A1. Yes, this might be able to check for it. I think I just have to check this out. So let's see. Right? No, because the mouse is where we move, and that's what we're attacking. Right? The mouse is what we're attacking. Or not. The mouse is what I'm attacking. Meaning... Yes, we bind the king to the mouse, and then we try to attack with every piece on the board. And if we can attack with one of the pieces, we return true, else we return false. So I guess maybe we can try. And let me put the king in a position. I need to put the king in a position where this is like fulfilled. Oh look, there's already happening something here. So let's try to put something in place so it can die. The king have to move here, and can take this. Okay. I don't want to check with this. I'm gonna check with this instead. Okay. And let's see what happens here. Okay, so for some reason it did not trigger the first one, or what? Free, that's fine. Okay, so what happens here? It's free. Why is it free? Oh, because we override the mouse, which we cannot do. So I cannot do it this way because I'm overriding the mouse, unless I do something where I override the mouse only during this, and then after that I go back to the real mouse position. But it's a very, very bad solution. Very bad solution. But you know, let me just check it out to see if it actually works. I kind of just want something, or I kind of just want it to work right now. And then what I would have to do. So true, does this need to return true? True if it is check. So I guess I do, it's not right, I flip it. I think I need to flip it. True, king is in check. Could also just do it the other way. Okay. So why is this not green is the question. What? Oh shit. Yeah, I cannot fuck. So do castling happens here, and I cannot return like this because this is in a loop and it will return multiple times, meaning do I have to push this to an array or something? Yeah, I'll just do it. I'll just do it. It's easier instead of thinking about how others would do it. So where did I move it? And it's not in check. So this is definitely have to be flipped. So it should also check chess here, or check, but it's not. It's not checking here, which means there is something wrong with some of this logic. So let's see. Okay. Interesting. Yes, yeah, that's fine. It's actually fine. It's like it should be. Yeah, this is not right though. What happens? Undefined. Ooh, I see. I guess we just do. I'll fix this way. Yeah, also the bad thing about this is that I check every piece. I do not only check the pieces of the enemy, which is kind of bad. But let's see if this triggers it. So it does trigger it. When P black yeah, this doesn't work. What am I thinking? Also these values there, why are they so why I why did like this? It's far out. Why the values? Okay, so this needs to trigger it as well. This field, but it's not triggering it. It's not good. Right, yes, this needs to trigger it, because the king cannot pass through the field. Cannot pass through. Okay, so it doesn't even get in here, because I check. Yes. So let's remove this return because I think that's what breaks it. And I might have to push these into an array or something. Oh no, I don't need to return actually. Because if it's true, then it should stop running. Because then the move cannot be done anyways. That's right. Or no. Yes, I have to do this. Because if I return false, then I do not check. So, no, I guess I can do if maximum stack. And if I is less than 7, I guess this is where I have to, or I could put I guess then I could remove this. Maybe. This is so messy. What the fuck? What the fuck? I is greater than equal to 0. Okay. So we have a green field. But we also have a green field here. Interesting. We cannot move here though, but we can move here. So I guess the movement works. Why do you use the increment? To hold some values, because so I don't need 2 or an if statement here and 2 for loops, because one of them I need to decrement and the other I need to increment in the loop. So this was one of the ways I thought it. So this holds the value for the loop to increment and decrement, and how long the loop should run, and a rule for the king as well. And I actually also have to, so here I would have to check one more thing, and or maybe I would do this here. So in this case, y has to be equal, or if y is not equal, that increment does first value, then we have to return false. Okay, so now it's red up here, but it's green. Okay, good. Okay, so this fails as well, which is not good. So why that happens, I do not know. Oh, it does. Oh yeah, it does. But up here it fails too. Here it works. Okay, so there's something wrong because it doesn't work here. It could be the bishop. So let me try to move the bishop, I guess. Yeah, it's not because of the bishop. Some other logic. The question is if it runs actually. Does it run? It doesn't even run. Doesn't even run now. I really need a break soon. This is too much. And why does it not print this? This should be running. Why is it not running? Okay, what is going on? It's not running this at all. Did I? Oh, shit, that's why. Okay, so let's see. Still not running. What is up now? Seems like it's just returning here. I don't understand. Seems like the function is not even being called now. Or then it's this debugger that's broken. Let me close. Yeah, it was the debugger. Apparently the debugger broke. Or the dev tools broke. So why this is not allowed, I do not. Why is this called so many times? What is up here? Oh, I see. That's an easy fix though. So free, it's fine. It's fine. So I wonder why it disallows this move. And it disallows it the other way down here. So there's some of the logic I have to look at. Most certainly this one. So I guess we map it out or something. So if I, which is in this case, I is gonna be 5 less than equal to 7 and 6 is equal to 6. So that is true. And here we have if I is greater than 3 is greater than, oh, greater than 5 is less than 3 is greater than equal to 0 and 2 is equal to 2. And this doesn't make sense. Oh, it does. So why does this not trigger it? Or okay, no. So it triggers, but something is wrong. And I guess what is wrong is actually this one. So it's not this one that's wrong. This one is correct. So it's this one that's wrong. So I is greater than, so 3 greater than equal to 3 or 5 is greater than equals to 0, no, 6 or 2. Oh, so this is maybe where I is less than how would I else do it? I'm not gonna put an if statement and then make 2 for loops. Might be another way. But let me not think about that. I just want to, like, the logic have to work right now. That's what I need. So 5 is greater than, and 3 is greater than 2. So most certainly is correct here. It's correct here. I guess what I could do is that I could log out these or something. Okay, so 3 is greater than 2. That's false. 3 is less than 2. Or 3 is greater than 2, that's correct. Isn't it? Five is less than equal to 6, and 6 is equal. Why is this not returning correct? Ooh, maybe it goes to this. Why? Because the Y is from the mouse. 7 is not equal 0, that's correct. Or wait a minute. It's not equal. Not equal, what does that mean? It's not the same as. So I guess it returns, what about this one? Oh, that's it, I guess. So it's definitely returning true in this case, and then we return false. And king is in check, returns true. Is it 7 0? Oh, oh yeah. Yeah, this doesn't work. That's why. Because this is not gonna be 7 in this case. This has to be y. If y equals 0 or 7, this might do it. 233. Okay, so it's green now at least. So I guess the rules, they're right. I'll let that stay. So when this happens, this returns true. Do castling. This returns true. So this would have to move another piece as well, right? So move the other piece. Or maybe I should do it inside the castling. Might be better to do it here. Let's see, wait a minute, what am I doing here? Oh no, okay, so it is right. Do I even use? I guess I don't need this. Oh, I can still do this, which is not good. Is king check rule? So what does this return? So this returns true, 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 true. This returns false. Yeah, I'll take a break, so see ya.